Alrighty, part two of the story of Ed Leedskalnin's magnetic generator. Well, came in my workshop this morning and my Jesus was upside down, my cross upside down, and 10 magnets were scattered throughout the floor. I am beside myself thinking about what the hell happened in here. But I don't know. So let's go ahead and start off here. I'm going to tuck this right here. This is Ed Leedskalnin's magnetic current, the ones with the pictures. And we'll start off in this section right here. Now about the generator. Talking about this thing. In the first place, all currents are alternating. To get direct currents, we have to use a commutator. Transformers and generators of any description are making currents in the same way, by filling the coil's iron core with magnets and letting the iron core push them out into the coil. You can see right there, you got a saturation and then you got a depletion. Connect the battery with the electric magnet, and he's talking about the PMH, okay? It will be a field magnet now. So now we can identify this being a field magnet. Put a 3-inch coil between the iron prongs and take it out. Do it fast. Repeat it. Then you will have a steady light in the light bulb. Okay, so instead of messing my PMH up and doing it with that, I have a little one here. I got LED hooked up to it. And since I have one hand holding the phone and one holding this, I can't turn the wheel. So what we're going to do is move this aside. We're going to get the wheel turning. And we're going to put that up against the magnetic flux. Okay, we don't see anything happening there. So this shows that speed is very important. And Ed's going to talk about how important speed is. There we go. You see he has the light. Try that again. We just seen the light up green. So speed is important. And what we're doing is filling up the iron core. With magnets by using the coil around it. I'll get you guys some good light so you can see that it does produce, but every time I let go and stop the spinning or slow the spinning down. There we go. Alright, so you can see it lights up. But because I'm not constantly turning it fast, that it doesn't do it. So going back to the book now, it says on page 43, now you in the field magnet are a generator. Suppose you had a wheel and many coils around the wheel turning. Then you would be making all kinds of light. Do not make this machine. I already have the application for patent in the patent office. I made 10 different machines to make magnetic currents, but I found a combination, you ready guys, between field magnets and coils to be the most efficient. Field magnets, so we're talking magnets, a couple of these, and coils. The most efficient. Put a coil in slowly and take it out slowly. Then you will have no light. That will show to make magnetic currents that time is important. And we just found that out, right? So time, speed is very important in the process here. Put a 6-inch long square rod on top of the two iron prongs. Fit good so it lies even. And he's talking about this iron keeper bar on the prong ends right here, okay? Connect the battery with the electric magnet for a little while. Now disconnect the battery. Connect the light bulb with the electric magnet the same way it was connected with the battery. Now pull it off the 6-inch long bar. Do it quickly. Then you will see light in the bulb. So he's talking about the PMH and connecting it to the coils, and when you pull the bar off, you'll see light. And right now, we have this set up without the coils on it, but you get the gist of it. Next page is 44. It says, connect the battery up again with the electric magnet. Put the bar across the iron prongs. Hold a while, disconnect the battery. Now the electric magnet holds perpetual motion. If not disturbed, it will last indefinitely. I held it in this position for 6 months, which we're going on a couple months here. It's stuck, shouldn't be. This experiment shows that if you start the North and South Pole individual magnets in an orbit, they will never stop. There's his pictures. There's the schematic. I'll hold this up. There's a schematic of Ed's parts for his PMH. Okay, you guys can just snapshot that. Here's another one of the PMH. That is this guy right here, and it shows the dimensions, the coil size. There's the 6-inch keeper bar right there. The hanging magnets that hang up and down, they will show that there is motion inside the bar. So what he did was he moved the bar around the hanging magnets, and he can see that there's motion still going on inside this whole apparatus here. He says, hold a perpetual motion holder, North Pole magnet or pole east, and South Pole magnet terminal or pole west. Now raise it up and down, or raise it up slowly to the South Pole hanging magnet. Then you will see that the South Pole hanging magnet is swinging south. Now put the perpetual motion holder under the North Pole hanging magnet. Raise up slowly. Then you will see the North Pole hanging magnet swing north. Okay. This experiment shows without any doubt that the North and South Pole individual magnets are running in the same direction as those in the copper wire, which came out of the car battery. In both instances, while the magnets are running ahead in swirling motion, they use the right hand twist. Now it says get a magnet and make it so you can turn the magnet, return it, wound if possible more than 2,000 revolutions per minute. Connect the light bulb. So last time I did this, we actually burnt out the LED. So I got my magnet, got my 2,000. I'm not going to do 2,000, but you see how it sucks in. So we got it disconnected. All right, I can do it better. Sorry about that, guys. Let's try it now. So we already blew the bulb. So we're putting so much damn current from spinning it fast. in there that we blew the LED, but you get the logist of spinning it fast. Okay. Now going on to the next section, we spun it. We spun it fast. Um, Ready. So we just displayed how Ed shows how we take iron core, we fill it up with magnets, and then we stop the process, and then the magnets will come out through the copper into the light. Okay. Now we're going to get into a section of Ed's other book, and it's inside there, but I just don't know where it's at. And then this one here, it says take the coil out of electric magnet. No, that's not to get. Oh, here we go. To get more magnet out of a coil, put the coil in steel or iron tube. Then the tube outside the coil will be a magnet, the same as the coil's core, but the magnet poles will be the opposite. It means at the same coil end, if the core end of the North Pole tube end will be South Pole. In this way, you will get almost again as much magnet out of the coil and in the core and tube. You can do better yet. Join one end of the coil's core and with the same metal joining core with the tube. Make the two holes in the end of the metal for the coil wire ends to go up to go out. Fasten the ring on top. Now you will have the most efficient magnet for lifting purposes. It wastes no magnets that come from your battery or dynamo. Now let's go back to this. I did mention that there is another one of these flanges, a ring, that's attached on the back there. Now what Ed has done, he has taken that pole, and here he created what he describes as a beautiful pulling apparatus. So he's able to create 4 poles inside the casing that he's saying, and here's the same casing over here. So he's saying that this core, this would be a coil, imagine a coil in here, 1500 turns. He would have, this core would be north, this outside layer would be south. On the flop side, the core would be south and the outside layer would be north. So he's creating a switching system in this coil. So this coil, you can see in the back of this coil, this box here on Ed's picture, he's got like a screw going across this way, 2 chains and a wire. Okay. So I would suspect that the chains would be to capture magnetic flux, and the wire through the coil would to capture electricity, alternating current. Okay. In regards to this apparatus that's along the top, it has a twofold, which one would be hold the mechanism down, because when the magnets go by the core and this, it's creating a lot of magnetic field here. So on the box here, it would be where this rod, flat rod, hangs over like this, and you can see it in the picture. Well, when it hangs over like that, it it sits right above 3, I gotta say, right there, 3 of the magnets. So what we would have here, at any given moment with the wheel turning, we would have a north and a 2 souths, and or we would